back to physics class. So I hope all of you learned the previous topics very well. So today we are going to discuss about projectile motion. It is one of the most important topic in this chapter. So as an application of the ideas developed in the previous section, we consider the motion of a projectile. So what do you mean by projectiles? So projectile means an object projected in space or air such that it moves under the effect of gravity alone is called projectile. So what do you mean projectile? An object projected in space or air such that it moves under the effect of gravity alone. We call it as projectile. Suppose a bullet fired from a gun is also in projectile motion.
A body that is in flight after it is thrown or projected is called a projectile. The motion of the projectile is the result of two separate but simultaneously occurring components of motion. One is the horizontal component without any acceleration, and the other is the vertical component with constant acceleration due to gravity. We neglect the effect of air resistance on the motion of the projectile. The initial velocity of the projectile is v0. Initial angle of projection with the x-axis is theta 0. The horizontal component of the initial velocity v0 x is v0 cos theta 0. This horizontal component remains constant throughout the flight, as the acceleration in the x direction is 0 and air resistance is negligible. The vertical component of the initial velocity v0y is equal to v0 sin theta 0. This vertical component keeps on changing with its position and lapsed time of the projectile, as the vertical component of the projectile motion has an acceleration equal to the acceleration due to gravity. Here, A is equal to minus gj, Ax is equal to 0, and Ay is equal to minus g. Consider the origin is at the initial position of the projectile. Therefore, x0 and y0 is equal to 0. Now, let's find the position coordinates of the projectile at any time t. Consider the horizontal motion x is equal to v0x into t. On substitution, we get x is equal to v0 cos theta 0 into t. Let this be equation 1. Similarly, vertical motion can be written as y is equal to v0y into t plus half at square. On substitution, we get y is equal to v0 sin theta 0 into t minus half gt square. Let this be equation 2. Now, we can write the components of the velocity of the projectile at any time t. Vx is equal to v0x, which is equal to v0 cos theta 0, as the horizontal component Vx always remains constant. As the vertical component of the projectile has acceleration equal to minus g, it keeps on changing with time. Hence, Vy is equal to v0 sin theta 0 minus gt. Now, let's write the equation of the path for the projectile. By eliminating t from equations 1 and 2, we can get the equation for the path of the projectile. From equation 1, we can write t is equal to x divided by v0 cos theta 0. Let this be equation 3. Substituting equation 3 in 2 and simplifying, we get y is equal to tan theta 0 into x minus g divided by 2 into v0 cos theta 0 square into x square. Let this be equation 4. In this equation, tan theta 0 and g divided by 2 into v0 cos theta 0 square are constants, as g, theta 0 and v0 are constants. As you know, the equation of a parabola can be written as y is equal to ax plus bx square. Let this be equation 5. In this equation, a and b are constants. By comparing equations 4 and 5, we can conclude that the path followed by a projectile is a parabola. Let's now find the time taken for the projectile to attain maximum height. At the top point, momentarily, Vy is equal to 0. Substituting Vy is equal to 0 in the equation, we get the expression as shown here. Tm is the time taken to attain maximum height. Therefore, we can write Tm is equal to V0 sin theta 0 by g. Let this be equation 6. Now, let's find the time of flight of the projectile. Time of flight is the total time during which the projectile is in motion. When the flight ends, y is equal to 0. If Tf represents the time of flight, then Tf is equal to time of maximum height plus time of descent. By the symmetry of the path of the projectile, which is parabolic, and time of maximum height is equal to time of descent. Therefore, Tf is equal to 2Tm. On substitution, we get Tf is equal to 2V0 sin theta 0 by g. Let this be equation 7. Next, we will find the maximum height attained by the projectile. Consider the maximum height of the projectile as h meters. This height is reached in time Tm. Substituting in equation 2 and simplifying, we get h is equal to V0 sin theta 0 square divided by 2g. Let this be equation 8. What is the horizontal range of the projectile? Here, the initial position of the projectile is 0, 0. The final position of the projectile is x, 0. X is known as the horizontal range, r, of the projectile. This is the horizontal distance travelled by the projectile during its time of flight, Tf. On substitution and simplification, we get r is equal to V0 square into sin 2 theta divided by g. Let this be equation 9. What is the angle of projection for the maximum range of the projectile? R will be maximum when the sin 2 theta value is maximum. That is, 2 theta is equal to 90 degrees. Therefore, theta is 45 degrees for r to be maximum. Let this be equation 10. Substituting theta equal to 45 degrees in equation 9, we get r max is equal to V0 square by g. The equation of the path for the projectile. y is equal to tan theta 0 into x minus g divided by 2 into v0 cos theta 0 square into x square. Time taken for the projectile to attain maximum height. Tm is equal to v0 sin theta 0 by g. The time of flight of the projectile. Tf is equal to 2v0 sin theta 0 by g. The maximum height attained by the projectile. H is equal to v0 sin theta 0 square divided by 2g. Horizontal range of the projectile. R is equal to v0 square into sin 2 theta divided by g. The maximum range of the projectile. R max is equal to v0 square by g. When a body moves in a circular path at a constant speed, it is said to be in uniform circular motion. As the body is continuously changing its direction of motion, its velocity changes continuously. Since the velocity of the body is changing, it has acceleration, which is known as centripetal acceleration. Let us find the magnitude and direction of the centripetal acceleration. Here, r and r' are the position vectors, and v and v' are the velocities of the body at points P and P'. As the body is moving in the circular path, the velocity vectors will be tangential to the circle at the points P and P'. The change in velocity delta v is obtained by using the triangle law of vector addition. V and r, as well as v' and r' are perpendicular to each other, as v and v' are tangential to the circle, and r and r' are the radii of the circle. Therefore, delta v is perpendicular to delta r. If we place delta v along the line which bisects the angle between r and r', the arrow of delta v points towards the center of the circle O. The average acceleration acts along delta v. Therefore, average acceleration E bar is directed towards the center of the circle. We can verify all these by changing the position of the point P'. As delta t tends to 0, the angle delta theta also tends to 0, and hence the average acceleration becomes instant acceleration. Therefore, we can conclude that the acceleration of a body in uniform circular motion is always directed towards the center of the circle. Now let us find the magnitude of the acceleration. As you know, the angle between r and r' is delta theta. As v and v' are perpendicular to r and r', the angle between v and v' is also delta theta. Therefore, triangle OPP' formed by the position vectors and triangle ABC formed by the velocity vectors are similar. From these similar triangles, we can write magnitude of delta V by V is equal to magnitude of delta R by R, where R is the radius of the circle. This can be written as magnitude of delta V is equal to V into magnitude of delta R by R. Magnitude of A is equal to limit delta T approaches to 0. Magnitude of delta V by delta T, which is equal to limit delta T approaches to 0. V into magnitude of delta R by R delta T. This expression can be written as magnitude of A is equal to V by R into limit delta T approaches to 0, magnitude of delta R by delta T. Let this be equation 1. As delta T approaches 0, delta theta also approaches 0. Arc PP dash is approximately equal to PP dash, which is equal to magnitude of delta R. Magnitude of delta R is approximately equal to V delta T. This can be written as magnitude of delta R by delta T is approximately equal to V, which implies limit delta T approaches 0, magnitude of delta R by delta T is equal to V. Let this be equation 2. Substituting equation 2 in 1 and by simplifying, we get A is equal to V square by R. Let this be equation 3. The acceleration of a body moving with a constant speed V in a circle of radius R has a magnitude V square by R, and it always acts radially directed towards the center of the circle. This acceleration is called centripetal acceleration. The word centripetal refers to center seeking. Now, let us find the centripetal acceleration in terms of angular velocity, omega. As the body moves from P to P dash in time delta T, the line OP turns through an angle delta theta. As you know, omega is equal to delta theta by delta T. Let this be equation 4. V is equal to arc length PP dash by delta T, which is equal to delta S by delta T. Let this be equation 5. Delta S is the arc length, which is R delta theta. Let this be equation 6. Substituting 6 in 5, we get V is equal to R delta theta by delta T. Let this be equation 7. Substituting 4 in 7, we get V is equal to R omega. Let this be equation 8. Now, substituting equation 3 in 8, we get centripetal acceleration AC is equal to omega square into R. Now let us find the centripetal acceleration in terms of frequency. Time taken to make one revolution, that is, time period is T. Frequency, F, is the number of revolutions in 1 second. Therefore, F is equal to 1 by T. Distance moved by the body in one revolution is equal to 2 pi r. V is equal to 2 pi r by T. On substitution, we get V is equal to 2 pi rf. Omega is equal to 2 pi f. Substituting the values in equation 3, we get AC is equal to 4 pi square f square into r.
Now we have to discuss some problems related with the projectile. Can you understand about projectile? So what is a projectile? An object projected in space or air such that it moves under the effect of gravity alone, we call it as projectile. Okay, so projectile means an object projected in space or air such that it moves under the effect of gravity alone. Okay, and also we have to derive some equations related with that projectile, that is time of flight, maximum height of a projectile, then horizontal range. Okay, so here what do you mean by time of flight? So time of flight means it's the time taken by the projectile from the instant it is projected till it reaches the point in the horizontal plane of its projection, that is the body reaches the point B. Okay, so this is the shape of a projectile motion. So here the body reaches the point B after the time of flight TF. We call it as what? Time of flight. So what is time of flight? It is the time for which the projectile remains in air above the horizontal plane from the point of projection. Okay, and also you have to derive the formula, that is TF is equal to what? Time of flight, TF is equal to 2u sin theta by g. Okay, so here u is what? Initial velocity. So in some other textbook u can also be written as v0. So v0 is also is what? Initial velocity. Okay, so the equation is TF is equal to u sin theta by g. Here u means initial velocity. Okay, u or v0. v0 is also is initial velocity. Then next one is maximum height of a projectile. So what do you mean maximum height of a projectile? So this one is the maximum height of the projectile. The greatest height, or it is the maximum vertical distance attained by the projectile above the horizontal plane of the projectile. We call it as maximum height of a projectile. Okay, so maximum height means it is the maximum vertical distance attained by the projectile above the horizontal plane of the projectile, and its equation is what? HM is equal to u square sin square theta divided by 2g. So u is also what? U is its initial velocity. Then g is acceleration due to gravity. Okay, then one more equation is horizontal range. So what is horizontal range? It's the horizontal distance traveled by the projectile during its time of flight. Okay, then its equation is what? R is equal to u square sin 2 theta divided by g. Okay, so you have to remember these three equations in your mind for solving the problems related with the projectiles. Okay, and also one more thing, you have to remember that the motion of the projectile is what? Which shape? The motion of the projectile, or trajectory of the projectile? The trajectory of the projectile is a parabola. Okay, and the maximum angle, when it reaches the maximum angle, when this angle becomes 45 degree. Okay, so the first question is, what are the angles of projection of a projectile projected with velocity 30 meter per second so that the horizontal range is 45 meter? Then take g is equal to 10 meter per second square. Okay, so you have to read the question 2 times, then write the which are the given terms in this question. What are the angles of projection? So you have to find out angle. Okay, so you have to find out angle theta. Then which are the given terms? Projected with the velocity 30 meter per second. So v is what? That means u is equal to 30 meter per second. Initial velocity is 30 meter per second. Okay, then also one more term is given, the horizontal range, that is capital letter R is equal to what? R is equal to 45 meter. Then also g is equal to 9.8 meter per second, or it is 10 meter per second square. Okay, so from this equation, which equation you have to find out theta? So here R is given, so R is equal to what? R is equal to u square sin 2 theta divided by what? G. Then substitute the values to find out what? Theta. Okay. So R is what? 45. 45 is equal to U square is what? 30 into 30. Then sine 2 theta divided by G is what? 10. Okay. Which is equal to 45 into 10 is what? 450 is equal to 900 sine 2 theta. Okay. So sine 2 theta is what? Sine 2 theta is equal to 450 divided by 900. Okay. Which is equal to what? 1 by 2. So sine 2 theta is equal to what? 1 by 2. Okay. So 2 theta is what? Which angle we got the sine theta is equal to 1 by 2. So sine 30. Sine 30 is 1 by 2. Okay. Sine 30 is equal to what? 1 by 2. So you have to equate these two equations. That is 2 theta is equal to what? 30. So 2 theta is equal to 30. Okay. And also you got the answer 1 by 2. That is sine 150 is also 1 by 2. Okay. Sine 150 is also what? 1 by 2. Okay. So 2 theta is equal to 150. Then theta is equal, from this equation theta is equal to what? Theta is equal to 30 by 2, that is 15 degree. Then or theta is equal to 150 by 2 is what? 17 degree. So this is the answer. Okay. Second question. The range of projectile when launched at an angle of 15 degree to the horizontal is 1.5 kilometer. What is the range of the projectile when launched at an angle of 45 degree to the horizontal? So you have to read the question 2 times and write the given terms. So here the range of a projectile when launched at an angle of 15 degree. So here there are two conditions. The first is the range of a projectile when launched at an angle of 15 degree. So here the angle theta is equal to what? 15 degree. To the horizontal is 1.5 kilometer. So here R is what? 1.5 kilometer. Okay. What is the range of the projectile when launched at an angle of theta is equal to 45 degree? Then you have to find out the horizontal distance R. Okay. So here theta is equal to 50 degrees, horizontal distance R is equal to 1.5 kilometer. Okay. So you know that R is equal to U square sine 30 divided by what? G. Okay. So sine 30 means the equation is U square sine 2 theta divided by G. So 2 theta means what? 15. Okay. So U square sine 30 divided by G, which is equal to U square by G into sine 30 is what? 1 by 2. Okay. So R is equal to what? U square by G into 1 by 2. Okay. So from this relation you have to find U square by G, because R is given in that question. So what is R? R is equal to 1.5 kilometer. So U square by G is what? U square by G is equal to 1.5 into what? 2, which is equal to 3 kilometer. Okay. So U square by G is equal to what? 3 kilometer. Then the question is you have to find out when theta is equal to 45 degree, then what is his horizontal distance R. Okay. So again you have to write the equation. R is equal to what? U square sine 2 theta divided by G. Okay. So here U square by G is what? 3 kilometer. So you have to substitute this value. Then also theta is given. What is theta? Theta is 45 degree. So which is equal to U square by G is 3. 3 into sine 2 into what? 45. So which is equal to what? 3 into sine 90. Okay. So sine 90 is what? 1. So the answer is what? 3 kilometer. Okay. When theta is equal to 45 degree, then that is also what? 3 kilometer. not degree, 3 kilometer. So the horizontal distance is 3 kilometer. Okay. Then the next question is, show that the horizontal range is maximum when angle of projection is 45 degree. So you note the point that the projectile moves the maximum range when its angle of projection is 45 degree. So the maximum horizontal range is 45 degree when it moves the highest distance. Okay. So here you have to prove that the angle of projection is 45 degree. Then in this case the horizontal range is maximum. Okay. So you know that r is equal to what? U square sin 2 theta by g. Okay. For r to be maximum. So in that case sin 2 theta is equal to what? 1. So sin 2 theta is equal to sin 90. Okay. Then you have to compare the angles, that is 2 theta is equal to what? 90 degree. Okay. So theta is equal to 45 degree. So in that case that projectile moves the maximum horizontal range. So